let me work out an example of an indefinite integral. Usually, the idea of an indefinite integral is the same thing as of an antiderivative. So for example, if we have an expression that looks like this, let's say that we have something like 2 times the square root of x plus 3 over square root of x, the whole thing squared, and then we divide by x squared dx. Suppose that we want to work out with that indefinite integral. Again, the main idea in here would be to find out what is the antiderivative of this function right here, which basically means that what we want to do is we want to find out a function whose derivative is this. In other words, let me just write it down in here. This means that we are looking for a function f of x such that its derivative equals 2 square root of x plus 3 over square root of x, the whole thing squared divided by x squared. So all I'm going to do is I'm going to expand this. I'm going to work out the algebra for this, and then we can work out the antiderivative. So the very first step usually is to work out the algebra, which means I'm going to work out the square, and then I'm going to work out the division by x squared over there. So this will give me 4x plus 9 over x plus 2 times 2 square root of x times 3 over square root of x. That is just expanding the square that we have divided by dx. Again, really what I did over here was nothing else but a plus b squared equals a squared plus b squared plus 2 times ab. So now you see that I have another expression. So all I'm going to do is I'm going to rewrite that expression, simplifying things. So the 4x stays the same, 9 over x stays the same, and now I'm just going to multiply these three terms. That will give me plus 12. And notice that I have a square root of x on top and a square root of x on the bottom, so that means that they cancel. So I have that the top part of that fraction stays as that, and then I just divide by x squared dx. So now this is a very important trick. What I want to do is I want to distribute this division by x squared. In other words, I'm going to separate it into three different fractions. 4x divided by x squared plus 9 over x divided by x squared plus 12 divided by x squared dx. And the idea for doing this is because if I have separate powers, if I have individual powers of x, it's much easier to figure out what is the antiderivative. So this means that the first part will be 4 divided by x, just a single x, plus 9 divided by x cubed, plus 12 divided by x squared dx. So again, notice that the only thing that I did was to simplify the expressions that I have, okay? Now, having powers is a little bit easier to deal with because we can work out the reverse derivative in this case, which if you have powers is pretty manageable. Let me just write them down in an easier way that we can handle them if you want. Let me write down the first one as 4 times 1 over x. Let me write the second one as 9x to the negative 3 plus 12x to the negative second power. Again, you see that the only thing that I did was to rewrite this expression. And really what I was looking for were expressions that I'm really used to work with. So that's the reason why I write down this divisions as negative powers, because I can work out basically the reverse of the power rule for antiderivatives over there. But notice that I did something different for 1 over x, basically because I can recognize 1 over x as the derivative of the natural log. So this is a very special case. All the other powers are pretty straightforward, but we have to be careful that 1 over x is actually the derivative of natural log. So that's a little bit different. Okay, So in order to work out this indefinite integral, in order to work out this antiderivative, the only thing that I have to do is I have to do the antiderivative of each individual term. I have to reverse the derivative for each individual term. So for the first one, you can probably see that this will be just 4 times the natural log of x. And again, one way to check that we're doing the right thing is that if we try to take the derivative of this that I just wrote, I get exactly what I had before. So remember, what we're doing is a reverse derivative. Now for the remaining 2 terms, usually the trick is to do the reverse power rule, which means I'm going to, instead to subtract 1, I'm going to add 1 to the exponent, and instead of multiplying by that number, I'm going to divide by that number. So the reverse power rule is basically you get whatever exponent you have, add 1 to it, and then divide by that same number. So I have the antiderivative of the first part, the second part, the third part, and then as we saw in class, we have to consider all the families of antiderivatives. That means that we end up adding this constant in the end. So all I'm going to do now is I'm just going to simplify the expressions that I have. So I have 4 natural log of x plus, this will give me 9x to the negative 2 divided by negative 2 plus 12x to the negative 1 divided by negative 1 plus c. And finally, I can write it down as 4 times the natural log of x plus, this should be minus because this guy is negative. So this will give me minus 9 divided by 2x squared. Again, I'm just rewriting the negative exponents as division. And then the last term should be also a negative 12 divided by x plus a constant. So really every time that we're starting with an indefinite integral, like what we had in here, what we need to do is we need to find a function whose derivative is the expression that we have inside. Usually the best way to go about that is by identifying the list of derivatives that we know, and usually the most common examples are going to be powers, like what we have over here. So the only thing to do is to do the reverse power rule. And then whenever we have this very special case of 1 over x, just remember that the derivative for that is a natural log. After that is basically simplifying the expressions, and of course don't forget about adding the constant. So indefinite integrals is just a different expression for antiderivatives.